Hi, I am Deards. I am a senior here at Stephen F. Austin University. I am in the geology program with a concentration in geoscience, and I'm here to talk about my S.U.R.E project that I did this summer. My project was in central Arkansas in a former Chert quarry that is in the range of the Ouachita Mountains. And so, because these walls are really well exposed, we're able to see a ton of folds, large ones to smaller ones, throughout the entire outcrop, and it is a treasure trove of structural data. And so my prerogative was to get information, get structural data from across this quarry and seeing how these folds line up with the already published literature of the Ouachita Mountains and how it is related, but also gain experience in creating a photogrammetry model. Because of these walls are really high up and it's really steep and dangerous and there's a ton of vegetation, it was not a good idea for me to get up there and take some measurements. So in order to have the accessibility that we needed, I was able to fly a drone, take a variety of photos, 401 to be exact, and take photos just with 70% overlap of different angles across all of these walls. And then I was able to then turn that into a point cloud and then finally into a model that would be able to have measurements taken off of it. For those softwares, I used Agisoft Metashape and Cloud Compare, and that allowed me to get the measurements that I needed to put into a stereo net, which allows me to get data. And the data that I was looking at were how it was folded, which directions it was folded, and then also trying to compare the plunges of the folds. Plunge is, layman's terms, it is kind of the way that it is going down, and trying to compare that to different folds across this outcrop. And we found that it was the direction of shortening was consistent with the Ouachita orogeny, which is the mountain building event. And it was able to be in the southeast and northwest direction. And then along with the plunges, there was one fold that I was really excited to look at. It had a very characteristically M shape that was on one wall and then another wall, almost like if they were to be connected. If I could make sure that I could take out the layers and put them and project them, I thought that they would be connected. And when I was able to take my data from it, the plunges were very similar, but not similar enough. So it was almost like it was going in two directions. And that was super interesting. I was not expecting to find that. And if I take this project further, I would like to try to find some more evidence of how it was deformed. These beds were created, the folds were created through a mountain building event, and that involved here was two tectonic plates colliding. So I want to see if there was something to do with that, either collision or separation or something else entirely that maybe caused the plunges to change. And so that was really fun to find out. But this project was really fun. It allowed me to create a digital model, which was a first for me. And I think that really, in data collection and all these things, it improves accessibility for people that need to get a ton of data, but they can't afford, or it's too far away to get the information they need. And so within 2 days, I got all my information and I was able to take my data with me wherever I needed to do. So I always had my model in my pocket. That was really fun. I want to thank the College of Mathematics and Science for funding the S.U.R.E program and allowing it to occur. I learned a lot. It was very educational, and I would thank all the faculty that was involved in it, and especially my mentor, Dr. Fleming, for teaching me throughout this whole process and guiding me to get my results. Thank you so much for watching, and I hope you enjoyed.